Howdy, this is your friendly neighborhood physics teacher here, and we're going to go over your dimensional analysis homework. Now, with dimensional analysis, there are different pathways you can take. So just because you didn't go the exact same pathway I did doesn't mean it's wrong. If you did a pathway and you want to double check, just send it to me and I'll gladly look over it and let you know if it's right or if that one works. So that being said, if your numbers were a little bit different than mine, I kind of worked it different ways and see if that your answer, so you and your buddy might have done it two different ways. Your numbers were off just a little bit, but that's okay. I still accepted that work. But let's start with number one. Again, my number one might be different than your number one because I had the questions scrambled, but there is a problem that stated that you have 66,893 centimeters, and it wanted you to go to miles. So we're going to do railroad tracks. This seems the best way to keep myself organized. If you want to do anything else, you can. I just like the railroad tracks because, like I said, it keeps me organized. So we have to start with centimeters and we need to get to miles. Anytime I have like a prefix with a base, I want to get back to the base. So I'm going to take that prefix, that centimeters. I don't want it anymore, so centimeters are going to get shunned to the bottom, and I want to convert it to meters. And that's just dealing with a little bit of metrics. So hopefully you know that for 1 meter, that's 100 centimeters. Since we have a centimeter on top, a centimeter on bottom, they cancel out. But we don't want meters, we want miles. So again, meters is going to go down to the bottom, so I can cancel out, but I want miles. So this information, for 1 meter, you have 0.000, I'm going to erase miles so I can write this number out. So 3 zeros, 62137. So I just Googled that. If you're going off your conversion chart, that should be in your chicken duck or in your notebook. I think it goes from kilometers, or it goes from, instead of meters to miles, it goes from kilometers to miles. There's just one less, or there's 2 less zeros. But I just did that. Now, meter on top, meter on bottom, we want miles. So now we just multiply across the top. So we take that 66,893, multiply that by 0.00062,137, and we get 41.5653, and there's more numbers, but that's as far as I'm going to go. We're going to divide that, and 100 times 1 is just 100. So now we can just divide that number by 100, and you get the answer to be 0.41565. Oh, I should put miles up here, and there's no unit, so miles. That's in standard form. We always want to be in scientific notation, so the decimals got to move 1 over, going from a smaller to a bigger number, so it's going to be a negative. So our answer is going to be end up 4.1, round that up to 6, e to the negative 1 miles. So that's our number 1. My number 2 stated that we want to convert 55 miles per hour, and we want to get it to meters per second. Now we're converting miles to meters and the hours to seconds. So again, I like doing the railroad tracks. It just organizes. So 55 miles per 1 hour. So that's just saying you're able to move 55 miles in 1 hour. We're trying to get to meters per second. We're just going to focus in on one of the units. So the first, and we're going to do these in two different colors here, so it kind of stands out what unit we're dealing with. So let's focus on the miles first. So miles is on top. We don't want miles, so miles have to go on the bottom. We're trying to get to meters. So we just stated that for 1 meter, it's this, and I'm going to erase this so I can write the number again, 0.000621371 miles. So that causes our miles to cancel, and we want meters, so we're there. We're good. Now we need to get our hours to seconds. Well, hours is on bottom, so hours is going to go on top. I know that hours to minutes for 1 hour is 60 minutes. And so that causes the hours to cancel, but we don't want minutes, we want seconds. So again, minutes has got to go on top, and we want seconds. So for 1 minute is 60 seconds. Yes, you can go ahead and do that in one big swoop, and you don't have to break it down into 2 times if you don't want to, but that's just how my brain works, so that's what I do. And we want seconds. So now, make sure everything's crossed out on top except for meters. Make sure everything's crossed out on bottom except for seconds, because we want meters per second. Now you just multiply. So 55 times 1 times 1 times 1 gives you 55 meters. And then that number times 60 times 60, 0.000621317 times 60 times 60 gives you a 2.2369, and it keeps going, but that's as far as I'm going to do seconds. Now you just divide those numbers, and you get a 24.587 meters per second. That's in standard form. To put it into scientific notation form, you're going to move it over 1. You're going from bigger to smaller, so it's a positive. So our answer, come on, there we go, it's going to be 2.4, around 6 e to the 1 meters per second. So that's how you convert that one. The next problem asks you to convert 102 kilometers per hour. It wants you to get it into yards per minute. Again, this is a two-stepper. You just have to focus on one at a time. So for 102 kilometers, you can move that in 1 hour. So let's focus on kilometers. So again, let's go back to the base. So we don't want kilometers, so kilometers needs to go on the bottom so it cancels out. Let's go back to meters. So for 1 kilometer, that is 1,000 meters. Causes our kilometers to cancel out. But we don't want meters, we want yards. So meters needs to go down to the bottom, and we want yards. This one should be in your chart, but also you can just Google it. So for 1 meter, you get 1.09361 yards. Meters cancel out, we want yards, so we're left with what we want. So now we need to get rid of this hour. And yes, it's okay that it jumps that far, because it doesn't matter. Remember, with PEMDAS, it doesn't matter what you multiply first or what you divide first, it still just all works. So we don't want hours. Hour needs to jump up on top. And we want minute. So for 1 hour is 60 minutes. That causes our hours to cancel in minutes. So again, Just multiply across the top. So you get 102 times 1,000 times 1.09361 times 1 gives you 11,150, nope, hold on, 111,548.22 yards, because everything else is canceled out but the yards. And then you'll do the bottom, 1 times 1 times 1 times 60 just gives you 60 minutes. So you just divide that number by 60, and you get 1,859.134 yards per minute. Again, we need to put that into scientific notation. That is right, that's your standard form, but we need to move it 1, 2, 3 times. Going from a bigger number to a smaller number, so that's a plus. So our answer ends up being 1.86, because that rounds up, e to the 3 yards per minute. So fourth problem, it's a two-stepper again. So it's asking, come on, there we go. So it's asking you to do 636 grams per minute. Whoops. It wants you to convert that into pounds per feet. Hold on. Oh, centimeters. I was looking at the wrong one. I'm so sorry, guys. So 636 grams per centimeter, and once you get in pounds per feet. Again, we're converting two things. We just got to focus on one thing at a time. Just got to focus on one thing at a time. Let's focus on grams. We don't want grams, so grams got to go down to the bottom. And you can, so for 1 gram, that's actually 0.0022046 pounds. Grams cancel. We want pounds, so we're good there. But we need to get to centimeters to feet. So let's go ahead and centimeters is on bottom. We don't want centimeters, so we want it on top. Let's go ahead and go back to the base. We know that there's 100 centimeters and 1 meter. Our centimeters cancel. But we don't want meters, we want feet. So again, meters goes on top because we needed to cancel. And that for 1 meter, that's a horrible one. That was 1. 1 meter, there's a 3.28084 feet. Our meters cancel, and we're left with feet. There we go, come on. So again, we just multiply across the top, so we get 636 times 0.002204621 times 100. Oops, nope. Let's try that again. Times 100. I did times 10 instead of times 100. That's not good. So you get 140.1238956. And everything's canceled out but the pounds. Divided by 1 times 1 times 1 times 3.28084 gives you that number. Feet, everything's canceled out but the feet. So now you just divide those numbers. 1.2804. And so you get your answer to be 42, the answer to life now, 42.73719.401 pounds per feet. And you put that into scientific notation. So remove the decimal over 1. So we get the answer to be 4.27 e to the 1. pounds per feet. So this is an example where you can do it in different ways, because I did this in a different way than I presented it to you as the fill in the blank. Because we went from grams to pounds, but what I did on the fill in the blank, so we did 636 grams, 1 centimeter. So in the fill in the blank, instead of doing what we did up here, so for 1 gram is that, because I don't like dealing with decimals, we stated that for 1,000 grams, it's 2.204 or 2.204 pounds. The reason you could do that is because we had to move the decimal over 1, 2, 3 times. So instead of just 1 gram equaling that, we know that 1,000 grams can equal that. Just makes math a little bit easier. Grams still cancel, and you're left with pounds. Next thing I did is I went from centimeters, instead of going straight to meters, I went straight to inches. And then I went to inches to feet. And so for 1 centimeter, that gives you 0.3937 inches. Of course, 12 inches gives you 1 foot. You still get close to the same answer, which would be the 42.7 pounds per foot. Make sure everything cancels except for what you want, and you're good. So last question. This one was the word problem. So Sally Leadfoot was pulled over on her way and from one place to another, and by an officer claiming she was speeding. The speed limit is 65 miles an hour, and she was traveling 97 kilometers in 102 minutes. And that was her average. So she must have had an amazing physics teacher, because she correctly converted it, and the police and tells the police officer that she blank deserves a ticket. So you had to convert it. So we need to convert our 97 kilometers per 102 minutes. We need to convert that into miles and hours. So again, we're going to focus on the kilometers first. Kilometers goes down. We're going to go to meters. And then from meters, we're going to go to miles. So for 1 kilometer, that's 1,000 meters. And then again, 1 meter is the 0.000622131. Now we can do the same thing that we did over here and do like 1,000 meters for, so that's 1, 2, 3. So let's go ahead and do that. So let's say 1,000 meters gives you 0.62131 miles. Well, here we have 1,000 up here and 1,000 up here. That completely cancels. I mean, not that the kilometers cancel, but the complete number cancels. So basically, what we're saying is for 1 kilometer, there's that many miles. And if something like that happens, it's okay. If you're just sitting there trying to sit there and convert, it's okay. And then we need to get to minutes to hours. And so we know 60 minutes is 1 hour. Again, you just multiply across the top. So you get 97 times 0.62137 times 60. 616.3734. And we're going to divide that by 102. Oh, we didn't double check, make sure things canceled. So we have a minute here, a minute here. So we're left with hours and miles. Now we just divide that by 102. And we see that she was only going 35.45 miles per hour. So she wasn't going very fast at all. So no, she doesn't deserve a ticket. So hopefully that helps. If you have any questions, again, make sure you come to tutoring and have a wonderful day. Bye.